Afternoon again, everyone. I'm for Mykel Gonzales. So I welcome you to my presentation. So basically, this is just a brief overview of the Solid Edge portfolio as discussed with Sir Jerome kanina. Although pinakita niya overview in terms of the Solid Edge portfolio, but let's discuss each pillar of solution under Solid Edge. So by the way, for Mykel Gonzales. I am the applications engineer here in CIM Technologies Incorporated. Okay, so yung background ko po is I am a registered mechanical engineer. Yeah, sige. So there are many different types of manufactured products as you known already. So from industrial machinery, heavy equipment, energy and utilities, and so on and so forth. So these products are usually complex in nature in such a way that we have already adopted certain technologies to actually produce these items that are shown in the screen or as involved in our industries right now. So usually they are electromechanical, yung mga assemblies natin. Okay, now these products are designed by people working in small to large manufacturing companies in the industries that I've mentioned earlier. But another important group of designers, including those are working in startup manufacturing companies, independent makers, and academic institutions, which you represent. Okay. So Siemens' vision of tomorrow is an optimized network of digital enterprises sharing data and collaborating in the design, manufacture, and deployment of products and processes across discrete and process industries. So producing a sort of ecosystem of startups, small, medium business, and enterprise scale participants. So to realize this vision, there are actually 3 business imperatives that every customer like you yourselves must embrace. So turning today's complexity into tomorrow's operational excellence and hence competitive advantage. So first is, as Sir Jerome have already mentioned earlier, the comprehensive digital twin. So it must be comprehensive in that it covers the entire product and production lifecycle, and it must include a sort of closed loop to ensure actual performance data is fed back, which might translate to the iterative approach of the design, wherein we try to optimize our design as we go through and receive feedback. Okay. The second one is the companies must take a personalized approach. There are many on-ramps to digital transformation, so a single approach won't work for everyone. So there's no such thing as a one-size-fits-all solution. So companies right now need to be able to work at their own pace, enabling fast and predictable digital transformation, leading to optimized operational performance. Okay. Plus, companies must consider how to meet the needs of individual users. So especially for you guys working in the academic institution, there's likelihood of sort of customization for each student. Okay. And finally, no organization exists in isolation. Okay. Digitalization extends throughout the industrial ecosystem, and collaboration between organizations from, let us say, from academic institutions and as well as from the industries outside DIM, right, for those manufacturers, there should be a collaboration, effective collaboration between these organizations, and it is very necessary to create such value. Okay, so companies must create this industrial network effect from the suppliers, from the academic institutions, from the manufacturers, from even clients, partners, distributors, and so on and so forth. Okay, all collaborating with an ecosystem of what we call as engineering excellence. Okay, and this open ecosystem extends to the user level as well, as today more than ever turning the complexity into competitive advantage requires IT systems that work extremely well together. Yeah, so Solid Edge is actually a key part of the Siemens Accelerator portfolio, and is more focused on the requirements of small and medium-sized manufacturers. Okay, so it's sort of a gateway to the accelerator program or portfolio of Siemens. Okay, so Solid Edge enables manufacturers to create a comprehensive digital twin of their products and includes solutions for mechanical design, electrical design. We also have simulation, manufacturing, and technical publications. It even includes solutions for data management for all the technical data that is created and consumed when supporting the comprehensive digital twin. So it also facilitates collaboration both within manufacturing companies and with external resources, including suppliers and customers. Now, here are some of the key challenges that we have identified. Okay, talking with designers and manufacturers of products in many different manufacturing centers, which can be a sort of factor for the students or for you as academic institution to leverage and have to be or serve as a solution or one of the solutions to address such challenges. So we will look at these challenges in more detail and how using Solid Edge to create a digital twin of your product or your student's product help you meet these challenges. Okay, so let's start with the first challenge. So it's very basic. It's usually the start of any design per se. Okay, so designing mechanical components. So we have here the challenges basically is to have design quickly and accurately, to have an efficient approach in the designing of mechanical components. With Solid Edge Synchronous technology, it enables the user to actually add revisions when found necessary, especially from the feedback of, let's say, from you, lecturers or professors, or even as they go through in the different industry or when they graduate from their courses, probably they have more profound understanding with addressing this challenge. Okay. The benefits are the following. We have speed up design, make changes faster, and increase reuse of existing design data. Okay, now, if you're not familiar with the term synchronous technology of Solid Edge, which is one of the key factors or key differentiating factors among its competitors, so let me discuss to you what is the synchronous technology. Okay, now rather than dismissing this as sort of just a buzzword or just a term that makes you excited, so let me introduce to you why Siemens created it. So the most common type of CAD system available in the marketplace uses what's called a history-based modeling because it has great benefits such as being dimension-driven. Okay, it's so good in fact that Solid Edge has been a history-based modeler for around 20 years now and continues to provide this method. However, we've worked this way for so long that we've learned to ignore the not so good things, such as having to pre-plan the model. So one of the, I think the best examples for a history-based modeling solution would be SolidWorks. Okay, so the main disadvantage of having to use history-based modeling solution is that you have to pre-plan it. So for example, a student is given a sort of model to use to create a digital twin using a history-based modeling software. He has to plan it in such a way that he has to choose significant or probably a good view or orthographic view wherein he can place the sketches and add features and so on. Okay, and that might have disadvantages as the student goes along the design. As the design goes more complex, it would have implications that it would be harder for him to add revisions if found necessary during the late stages of the design. Okay, now looking for a better way to work, we can turn to the other modeling solution, which is the direct modeling, because this has some great benefits such as direct interaction, or which we call as a push and pull modeling solution. But there are downsides to this method too, such as being featureless. So usually, the direct modeling solutions does not contain or does not provide the user any feature tree or path tree or yeah. Okay, so how about taking the best of both worlds but leaving out the downside? So we have what we call as the synchronous technology of solid edge or Siemens. Okay, with unique items such as 3D driving dimensions and phase relationships to really synchronize these worlds. Obviously, yeah, so basically synchronous technology is not a third-party technology. It's basically you can simultaneously use both modeling solutions, both history and direct modeling under one environment housed in Solid Edge. Okay, if you have any questions, sir and ma'am, you can chat and probably I can go over them as after this presentation. Okay, so let me proceed. Now, the other challenge is to actually design sheet metal parts. So Solid Edge has tools or commands that actually make the sheet metal design faster and more efficient. Like, for example, we have tabs, dimples, for example, jogs, and so on and so forth. This would enable any user, for example, to create sheet metal as fast as possible with these features or tools. And also to note that you can still use the synchronous technology during the design phase. Okay. And then following that, Solid Edge also has a module of solution for structural frames. Okay. So it is a common engineering task for many industries. So there are tools and commands for fast and reliable framework design. So like industry standard frame sections, which enables the user for fast and easy creation of the structural frame elements necessary for their product design. So even for downstream processes such as creation of parts list or what we call as the BOM or the bill of materials is made easier with the identification of cut length for each individual components, miter cuts, we also have material total length and so on. And even weldments can be integrated in your structural frame design. Okay. And then following that is the designing of mechanical assemblies. There you go. So as easy as the part modeling can be in Solid Edge, using synchronous technology can still offer a lot of advantages in the assembly design environment. So much so with adding or creating revisions in the context of the other parts in your assembly can be quite helpful as well, because you don't have to manually get dimensions and so on. Okay. There are also, or Solid Edge offers engineering reference to generate designs for, let's say, cam, shaft, gears, and shafts, and so on. Okay. There are also standard parts, especially for bolts and nuts, that can be added in your assembly design, which also removes the time or lessens the time for the design of such assemblies. Okay. Following that, we have creating 2D drawings. So in the context of Solid Edge, after you have created your parts, you can easily generate the principal views and add necessary views such as auxiliary views, cut views, detail views, and so on. Even getting the dimensions while you're designing can be less hassle in terms of the tools that Solid Edge offers, such as what we call retrieve dimensions. So for example, if you have actually created or added dimensions while you designed your part, you can easily retrieve the dimensions that you've used rather than manually using the so-called dimension tool of Solid Edge. Okay. So the next thing is that it is important that the CAD software you choose is easy to use and is easy to access for designers and occasional users. So there are a lot of resources that Solid Edge offers for new users and as well as those for occasional users as well, even for students. So there is an available set of resources in the internet for the students to actually acquire or to actually take leverage. Okay, so and even so, Solid Edge has the superior translation capability. So it can actually open native files from other software such as SolidWorks, CATIA, ProE, AutoCAD files as well, even with third-party file formats such as DXF, IGES, STEP, JT Open, and IDX. So this allows flexibility for the designers, especially so that if they are using other softwares, for example, if they find it, for example, if they find other resources from the internet and they might want to have to add revisions rather than starting from scratch, they might do so because of the superior CAD translation of Solid Edge. Now, Solid Edge in Solid Edge 2021, they actually presented this subdivision modeling. So for complex surfaces, okay, it is a great way to quickly create aesthetic smooth forms. So with subdivision modeling, you start with a sort of basic mesh and then use a polygonal control or sort of a net. Okay. Cage to create your desired shape. So you can quote unquote subdivide surfaces and create finer meshes in specific areas to create specific features. Okay. So the great thing about this new capability of Solid Edge is that it is included right inside Solid Edge, and the surfaces and solids you create using this technology can be used in the downstream operations that Solid Edge supports, including, for example, photorealistic rendering, stress and fluid flow analysis, manufacturing, and technical publications, which is, in fact, quite difficult if you're just using a basic surface modeling technique. Okay. Now, Solid Edge also has solutions for reverse engineering because it is rarely, because a 3D scan is rarely perfect and modifications or preparation is quite necessary before doing any other modeling or applying any modeling tools or commands. So Solid Edge reverse engineering solution can help the user to make necessary revisions for post and processing of a 3D scan component using the so-called convergent technology of Siemens. Now, Solid Edge delivers tools that simplify phase feed preparation for downstream manufacturing. It also helps to clean up and add some level of precision by, let's say, removing sections of the mesh. It can also smooth facet shapes and also, so we can build B-rep or boundary representative surfaces on top of the facet body without tedious tracing and reconstructing. Now, this is actually a flexible modeling made powerful through convergent technology. Now, Solid Edge has solutions also for electrical design. Okay, so creating 2D wiring schematics for electrical circuits and wire harness can also be a challenge for manufacturers of products that include electrical components and the associated wiring. So you can do analysis, for example, if the wire is appropriate for the current, okay, if the wire sizing is appropriate for the current, and so on. So if you want to know more or about any details with regards to electrical design, we would really love to make another appointment for this one. Okay. And even harnesses as well. So it takes off any tedious workflow with regards to creating harnesses, connecting electrical circuits. Now, Solid Edge PCB collaboration provides an excellent solution for collaboration between electrical and mechanical disciplines, and the ability to bring design aspects back and forth. So, okay, so Solid Edge PCB collaboration supports the mapping of 3D models to and from both the Siemens PCB design solutions, which Solid Edge also offers in PADS Professional. Now, it also supports integration with third-party PCB design solutions through the IDX format. Now, so let's move forward with the simulations solutions of Solid Edge. So after we've made our design or assembly design, we usually subject it to structural analysis to see if it will perform according to our desired performance. So be it for deformation. So Solid Edge actually offers linear statics, vibration, normal modes, even for thermal analysis such as transient and steady state heat transfer, and even with multi-physics, like for example, a combination of thermal and your static analysis. Okay. This would also enable the user to iterate their designs according to the results acquired from the simulation analysis. Now, we also have SIM Center Flow EFD. So SIM Center Flow EFD is already embedded in Solid Edge for flow analysis. This ensures products to perform as required under the context of fluid flow and also as heat transfer as well. So it is all with the intuitive wizard to set up your analysis. It allows users, especially for those CFD non-experts, to actually use this, especially for students, of course, because what we want is to get the insight from the results of our analysis rather than having to tediously set up the study. Yep. And then the next key challenge is for the manufacturing. Manufacturing accurately and efficiently. So this is for machine operations. Okay. So the challenges following, like choosing best manufacturing process, even tool paths and errors and rework in manufacturing. So Solid Edge has what we call the Solid Edge CAM Pro. It also contains Solid Edge 2D nesting for sheet metal layout and optimization of the sheet metal sheets with your sheet metal designs. Okay, the benefits are the following. We have reduced errors and rework, and faster and higher quality manufacturing processes as well. So you can actually simulate the tool paths created with the model-based definitions. For example, when we created a part with a hole, with a defined hole, Solid Edge CAM Pro recognizes that and somehow helps you to create a toolpath that recognizes the actual feature that you have applied during your part design. Okay, so the Siemens solution is to create accurate and efficient 2.5, 3, and 5 axis milling and turning processes using Solid Edge CAM Pro, and it uses third-party CAM software easily and components modeled in Solid Edge. Now, Solid Edge also has a tool or set of tools to process 3D printing, which is quite in trend right now, especially for schools, I think. Many schools have actually acquired 3D printers right now. So you can easily set up your models, the models that you've created in Solid Edge, so that you would have to set it up in such a way that you will have minimal supports. You will analyze some holes if ever they are, and also orient your model accordingly to the context of your printer bed. Okay. And then we also have this collaborating with suppliers and customers. Under the context of the academic institution, probably collaborating with other, probably their schoolmate or their schoolmates, their classmates, or probably with their teachers. Can also be with, let's say, suppliers outside from your academic institution as well. So Team Center Share is actually a cloud based collaboration tool which works well with Solid Edge. So it does not only allow you to upload Solid Edge native files, but with the term of helping you to collaborate with other users from different CAD softwares aside from Solid Edge, then Team Center Share is the best tool for you. You can actually add some markups, some notes to efficiently collaborate with your team and create revisions and see their designs as well using cloud collaboration. Now, Solid Edge also offers photo rendering, both for still images and animation. So we have KeyShot. So if you purchase Solid Edge, or if you download Solid Edge, it goes with, the KeyShot goes with that as well. So the parts or the assemblies that you've created, or your designs per se, that you created using Solid Edge, you can easily export it to KeyShot and then add some sort of graphic images for presentation purposes, let's say for thesis, for example, or adding context to your designs as well. Okay. So this is what Solid Edge mainly is. So it is a comprehensive and scalable portfolio for product development. So as I've mentioned before, with the mechanical design, we have the core design. That is the part and assembly using Synchronous technology. Solid Edge also offers solutions for sheet metal design, subdivision modeling. It also has the P&ID design, piping design, even generative design, which is a tool, topology optimization tool. Okay. And then a reverse engineering. And then for electrical design, we have 4 solutions under that pillar. So we have electrical routing, wiring design, harness, and PCB collaboration. So as I mentioned earlier, PCB collaboration is mainly for mechanical and electrical design collaboration. And then for simulation, we have actually motion simulation from dynamics and kinematics of assemblies. You can also derive call this response of your assembly through time. Okay, or discretization of through time. We also have Solid Edge simulation, which is standard. We have the linear static, the normal modes, the heat transfer, and so on. We have advanced for vibration, and SimCenter Fluidity for Solid Edge is that for flow analysis and even for heat transfer. Now for the manufacturing, we have the 2D nesting, as I mentioned, the CAMPRO foundation, machining, and 5-axis milling. Solid Edge also has the pillar for technical publications, for faster collaboration with downstream processes. So technical publication offers solutions for better communication with manufacturing, or for, let's say, manuals, if ever the product is already produced. We also have data management. So Solid Edge has the embedded data management, which you can actually customize according to your needs. For example, you can set repository folders for obsolete files, let's say working files, even for those files that you think are in review. You can also set data management of Solid Edge can be used as well to validate some files for duplication of names, or the number of names, or where the parts are usually used for a couple of files as well. And I've mentioned before the cloud collaboration, which is the Team Center Share. Now, the package of the academic institution, so it's quite a lot. So, but we can email you this, the details of this. So actually, for the student version or student edition, it's free. So students can actually download it. But the only limitations that I've known so far for student edition is that the files created will not open in the commercial version. Okay. And then the 2D drawings that they will that they can generate or they use are watermarked when actually printed as well. So there's a solid edge name once printed. Okay, so that is just a brief overview of the comprehensive and scalable product development portfolio of Solid Edge.